Now, what do we know? We know that the function f of x is kx squared, so let's go ahead and plug that in here. So for this term here, wherever you see an x, we're going to replace that with an x plus h, which is what I'm doing with this. And then you just subtract everything from what you started with. Now, many of you are already stuck here because you're like, if I plug in 0 for h, don't I have 0 divided by 0? And it's true, but that doesn't tell you anything about what this limit is and whether it converges. So we need to do some more homework here. What I'm going to do next is x plus h is all squared. I'm going to go ahead and expand that. And if I'm wrong, it's totally okay. You guys should just give it a try, and if you get stuck, that's right. Go back and try something new. So x plus h all squared is going to become x squared plus 2xh plus h squared minus kx squared all over h. And still we have a problem. We can't plug in 0 for h just yet, and that's fine. Your first challenge, the white belt challenge, tell me what I should do here next. Okay, if you didn't see it, I'm going to multiply this k through to every term because that tells me I'm going to end up with kx squared minus kx squared, right? So if we can karate chop some terms and make this an easier expression to work with, don't know what's happening with my Zoom here, bear with me. If we can eliminate some terms, that's going to be easier, right? Okay. So now I'm going to go ahead and cancel out these two terms. We're going to be left with this simpler limit, hopefully simpler. Let's see if we can get the answer. Can we plug in a 0 for h? Well, not so fast. We still cannot, right? We've got a little bit of a problem here. Here's your red belt challenge. A little trickier, maybe not. What should I do here next? Okay, why don't we bring out this h term from both terms we see in the numerator, right? And part of your red belt challenge is, am I allowed to do that? Because if I do this now, am I allowed to just cancel out this h on the top and the bottom? Okay, if you don't see it, the answer is yes. When we are talking about limits, nothing says that if you were to be at the value of h, that we have to have continuity. You can do this totally fine with the limit. And I'm going to do just that. So after canceling out the h, we are left with 2kx plus kh, and the denominator is only a 1. Sweet, right? Now, if I plug in a 0 for h, this guy goes away, and you are left with the derivative of kx squared simply being 2kx. Now, my black belt challenge for you. How would you use the first principle if the original problem was kx cubed? You tell me in the comments below, and if you want some more derivative practice,